So welcome to the first part of this reporting automation series. In this series, I'll show you some tools and strategies to get you started on your reporting automation journey. We will start off with the basics. So in this part, we'll begin by setting up your PC with the relevant tools and implementing your first script. In each part, we'll look at some practical examples to introduce you to some of the key features, which will also give you an indication of the possibilities available. This series is aimed at the curious hands-on CFO, the controllers who are interested in increasing reporting efficiency and accuracy, or accountants who would like to eliminate some of the manual day-to-day. That said, anyone else who is interested to understand how reporting can be automated within their teams will also benefit from the content in these tutorials. Whether you plan to implement something yourself or get someone else to help you automate your reporting pipeline, this series will be relevant to you. Even if you never write code yourself, this guide will help you speak the language of modern reporting. When you're done with the series, you'll have a clear understanding of how report automation works, some of the key tools you have available to you, and how to use these tools together to build a solid reporting flow. Automating your processes not only creates efficiency, but if done right, it's easily scalable to your needs and creates much more reliable and consistent outputs. So with that, let's dive into part one, in which we will cover which tools we're going to use, setting up your environment, and creating your first script. You can also follow along with the written guide for this video, which you can find on veropraxis.com. I've also included the link to the show notes below. From here, you can easily copy and paste code snippets and commands and refer back to the text as needed. This video is going to be more interactive and detailed, but this written text on our website will be a useful resource. Let's start by looking at the different tools you need to download and install. For this series, we'll be working in Windows, so that's what I'll be covering. It won't be exactly the same on Linux or Apple, but it will be quite similar. First off, we're going to install a nicer command line terminal. Commander is a terminal for Windows that is easier and more powerful, offering a similar look and features to what programmers use on Linux or Mac. So go to commander.app, cmder.app, and download the latest Windows version, which you can find down here. Just scroll down, look for the download full, download the file. Essentially, to install this program, you simply need to put the zip file that gets downloaded into the folder where you want to keep the program and unzip the file. You can then add a shortcut to the cmder.exe file, so you can easily access it. You can put that shortcut, or you can pin it to your quick access bar at the bottom, your taskbar, or you can just add it to your start menu. Now open Commander. You'll have something similar to this. Let's check if you currently have Python installed on your PC. Just type Python --version and hit enter. If you have Python installed, it will show you the default version that your PC is using. Otherwise, you'll get some kind of error message or an empty response or something like that. If you don't have Python installed, or if your version is very outdated, for example, if you're seeing version 2.7, go to python.org and download Python for Windows. You can find it here under the download drop-down menu, and here you have the link to download the installation file. I suggest you use 3.13, which is the latest version at the time of making this video. If there is a later version, you can probably just install that and it should work just fine. The features that we're going to be working with during this series should be compatible with future versions of Python as well. Run the installation file and follow the installation prompts. When you see the option to add Python to path, I suggest you select that checkbox Adding Python to path means that you can call the program from any directory, as we saw earlier when we were checking the Python version. Once you followed the prompts and installed Python, just simply close Commander and reopen it just to make sure that it's registered the new program, and now run which Python again, and it should show you the version as we saw earlier over here. Great. So we have a terminal, we have Python installed. Now let's get somewhere decent where we can write automation scripts. Head over to code.visualstudio.com and download the latest version for Windows. Install it, add it to path like we did with our Python installation, and you may see an option to add context menu items or something similar. Adding a context menu item essentially means that when you are in your file explorer and you right click on a file, you will see an option there to open that file in Visual Studio Code. This is quite useful. If you want to, you can add it. And as mentioned before, adding to path just means that you can call Visual Studio Code from any directory, as we will see in a moment. So we have our tools in place. Let's set up one more thing. This one is optional, but I'll be showing you later in the series how to leverage large language models, LLMs, like GitHub's Copilot, to help speed up your coding, and will probably help you in your learning process as well. You will also notice during this series that as I use Visual Studio Code, there will be some code suggestions. These code suggestions also come from GitHub's Copilot. So if you want the same experience, then I suggest that you open a GitHub account. You can just simply go to github.com, sign up for an account, create your account, and sign up for GitHub's Copilot as well. There's a free version, which probably is enough for this tutorial. I'm using the paid version, so you may see some differences between how mine looks and yours looks. But for now, just sign up for the free Copilot version, and that should be enough for what you need. Once you have an account, follow the instructions, but you will essentially need to install the VS Code add-on. So let's go to VS Code. Over here on the left, you'll find a little section that says extensions. Click on that. I have some other extensions installed here. You don't need to worry about all of these for now. For now, the key ones which we'll be needing for this tutorial is the GitHub Copilot. Install this. I think when you install GitHub Copilot Chat is also going to be installed. If not, install that as well. It's going to ask you to provide your credentials. Put your credentials in and you're all set. While we're on the topic of VS Code add-ons, let's install the official Python add-on for VS Code, which has been published by Microsoft themselves. Install that one, and you should have everything you need for now. That's it. Close VS Code so that the changes get applied, and restart it. Or I think it will actually just give you the option to restart it, and we're all set. We now have all the tools in place that we're going to need. Let's head over to Commander once again. You can customize this app quite a bit. So for example, you can set which directory it opens up in. For now, just cd into the relevant directory where you want to create a directory to save your scripts for this tutorial. So for example, if you wanted to go into a reporting series directory like I've done, or I'll show you quickly how to make a different directory, you can say go to where you want to go by using cd and the directory, find your way to the directory where you want to work, make directory example, cd example. This would essentially put you into a directory where you want to work. For this tutorial, I'll be using a directory called reporting series. You can name it the same. It's probably a good idea so that everything lines up nicely. And we go into the reporting series directory. So make sure you're in the correct folder. In Python, you can create virtual environments which you can activate for your scripts. This allows you to set which Python version you are using and which libraries are installed without having to do that for the entire system. This way you can isolate environments according to purpose, with each environment having the relevant specs for your particular project. For example, you might have a reporting project and a small website. These two projects probably use distinct sets of libraries and maybe even different versions of the same library for compatibility reasons. So you can create one virtual environment for each project and activate the respective one depending on what you're working on. You can even use a virtual environment with a specific version of Python you might want to use for that project. So you could have one virtual environment running Python 2.7 because you have a very old application that depends on that version of Python, and you can have another virtual environment that is running your default 3.13 in this case. So to get started, make sure that you're in the correct folder. In this case, we're using tutorials and the subdirectory reporting series. Type the following to create a new virtual environment that will use your default Python installation. So we'll type Python -m venv, which is the module we're using to create virtual environments, and reporting env will be the name of the virtual environment. Python tells the system to use the default Python interpreter, which in my case here is Python 3.1, 3.2. That's the version of Python that will be used inside this virtual environment. The flag -m essentially tells Python to run the venv module as a script. Venv is the library we use to create the virtual environments, and reporting-env is the name we are giving to our virtual environment. You can change this to whatever you want, but for this tutorial, you might want to just keep it the same for the sake of simplicity. Hit enter, and it's going to create the virtual environment for us. So we can see that's done. It only takes a few seconds. Once we're done, we need to activate the virtual environment before we install the libraries we're going to need for our project. In the same directory, simply type reporting environment /scripts /activate.bat. You can leave the .bat out. You can leave it in. It's going to do the same thing. Hit enter. Now you can see the virtual environment name on the terminal prompt. Your terminal may look a little bit different to this, but essentially you're going to see reporting environment in some form, in some color, somewhere on this prompt. And that way you know that you're currently in the virtual environment called reporting environment. Make sure you are in the correct virtual environment before proceeding with the library installations in the next step. If you're not in the virtual environment and you install the libraries, they're going to be installed system-wide, and that's not going to be the most convenient approach. So make sure you're in the virtual environment, and then let's type pip install pandas matplotlib open pyxl and requests. Let's break this down a second. Pip is a module or a little program in Python that helps us easily install libraries. So we say pip, we want to install, so we say pip install, and then we put pandas. Pandas is a powerful data manipulation and analysis library. This is going to become your new Excel. It allows us to work with large and complex data sets very efficiently, as you will see in the series. Matplotlib is a plotting library for creating static, animated, and interactive visualizations in Python. So this is what we'll be using to make our charts, OpenPyXL is a library that helps us when we are reading and saving Excel files. And requests is a simple HTTP library which is used to access online information, like working with APIs, for example, or reading a website's contents. So hit enter, and this is going to install the four libraries that we have stated here. So it's collected all the packages. You can see there's a lot more packages that have been collected than what we've stated. This is because some packages have some dependencies. So pip will automatically find those dependencies and install them accordingly so that your libraries work as they should. Okay, so the libraries have successfully installed. We have a little warning here that says we're running an outdated version of pip. Let's upgrade that quickly, just so that we are running the latest pip version. Upgrade will upgrade an existing version of pip. This command is slightly different because we're actually using pip to upgrade pip, so we need to format it a little bit differently like this. Hit enter. So that's done. Let's just clear the screen so it's nice and clean. So we have our virtual environment created. We've installed the libraries that we're going to be needing, at least for this part of the series. We can now start creating our first script. So as you remember, we added VS Code to the path. So this allows us to call and open up VS Code from where we are. So type code space dot, hit enter. This is going to open up VS Code in the directory that you called the command code space dot from. So you can see here we've got our virtual environment directory, and I have a folder here of datasets which we'll be using in later parts in the series. For now, you don't have to worry about that. Other than that, we have no files here. All right, let's create our first script. Go here and open the new file. Create a new file rather. Let's call this file Fred underscore chart.py. Hit enter. So you can see we have a new file here. Before we do anything, let's just add a comment here. In Python, to add comments, you just add a little hash and a space. You'll see it turns green. Now we can add the comments we want. These will not be read or executed by the Python interpreter. So we're going to make a, and you can see GitHub Copilot here is trying to auto suggest what we want to write. I'm just going to overwrite this for now and write my own. We're going to make a simple script that fetches data from the Fred API and puts it into a Pandas data frame. 2, we'll do some basic data cleaning, and 3, plots the data using Matplotlib, and finally saves the plot to a PNG file. Now, GitHub Copilot will basically build this for us, but we're not going to use that. We want to go through it one by one so that you can see the process and understand what's involved. So let's start by importing the libraries we need. To import a library in Python, you simply put import pandas as PD. As you can see, Copilot is already suggesting everything that I need to import. We can use this, or we can just type it ourselves. In this case, I'm just going to use what it's suggesting, because it's actually exactly, well, over here it was a little bit different, so I'll just override this, but for the most part it's giving me exactly what we need. So string IO, sorry, not OS, IO, from IO, import string IO. What is this saying here? This is telling us here, import pandas as PD. When we say as PD, we can now use pandas, and as opposed to always having to write pandas, we can simply write PD when we want to use pandas. You can call this whatever you want, but PD is typically what is used conventionally to call pandas, so I wouldn't change it, because most of the scripts out there and tutorials that you come across, they are going to have it as PD, and I would just keep it the same. Import matplotlib.pyplot as plot, so we can call that using plot. Import request, we're not giving this a separate name, so we'll just use it as request. And then the last one, from the module, from the library IO, import specifically string IO. So this is telling us that we don't want to import the entire library, but only the string IO function or feature of this library. So we've imported all the libraries that we're going to need for this. String IO, by the way, is going to help us when we're saving the chart to a file. That's why we're importing this. Request is going to help us make the request to the Fred API, and the other two we've already been through. Now let's define some variables which we're going to use. Firstly, we're going to need an API key for the Fred API. Over here, just put your API key here, replace it with your API key. We're going to need an API key to pull data from the Fred website. Setting this up is free, and I'm not going to go through specific details on how that can be done. You can just head over to the fred.stlouisfed.org. You can sign up for a free account, create a new account, and then you can just log in. Once you log in, under your account, you'll see API keys. Just simply apply for a API key. I think it's immediate. You'll basically just get an email within minutes or seconds providing you with your API key. So you'll take that API key that it gives you, or you'll have to come back to the site to specifically find it, and copy that API key and simply place it here. For the sake of privacy, I'm going to quickly create a separate file where I'm going to place this API key, so it's not visible in this script. Okay, so I quickly just created a config.py file here so that my API key stays hidden, and you can do something similar for privacy reasons, or you could just add it to an environment variable, which is actually the correct way to do it. But for the purposes of this tutorial, I'm just going to do it quickly this way. So I've created a config file, config.py, and I've put in the API key there. So what I'm going to do here is I'm going to say from config import Fred API key. And over here, I'm going to replace this with my Fred API key. Once we've got that, for this example, we're going to use, we're going to look at GDP data for the USA. So I already know, and I've already looked up on the Fred website, that the series ID for GDP is simply GDP. So we're going to define the series ID as GDP, and we're going to put the Fred URL equal to this. A little bit about this Fred URL string, which you'll find useful for other applications as well. But essentially, we're putting this little f here, which turns this into what's called in Python an f string. An f string essentially allows us to define a string in this case URL, and by inserting variable names like series ID and API key within curly brackets like this, this essentially just embeds the value of these variables within the string just in line like this. So it's a very convenient way to define a string and then be able to insert information based on variables within that string as the script runs. So here we have the URL. This URL can be found from the API documentation on the Fred site. We're including GDP as a series ID, and we're including our API key over there, and we're saying that we want the response to come back in the form of a JSON. Now we're going to want to retrieve the data. In order to do this, we're going to use the requests library that we imported. So let's make a request like this. We will say response, which will be the variable where we will store the request. And we're going to say equals requests dot get Fred URL. Okay, let's turn the response into an actual JSON format within Python. So we're going to say data is equal to response dot JSON. I see I have a typo here as well. That's why that's not working. Okay, so we take the response of our request was saved into a variable that we called response, and then we converted this response to JSON and saved that into a variable called data. Okay, and lastly we want to define a variable called observations, which is essentially going to look at the data variable and extract all the data that we will find under the JSON key called observations where the data is stored. How do I know this? I know this because I've already checked and I've worked with Fred data before. In later parts of the series, we will actually look at more interactive ways within Python where you can extract the data, show the data here, but for the purposes of this tutorial, simply because we just want to create a first script and see how easy it is to get data and generate a chart, we're not going to go into those details at this point. Let's correct this to observations. Okay, so now we have our observations data, which is the GDP data. We want to ensure that the value column is numeric, and we want to ensure that the date column is treated as dates. We also want to remove any missing values, so any null values as is called in Python. Go ahead and type df. We're going to define a variable called df, which stands for data frame. That's a pretty common convention. We're going to say pd data frame observations, and this is going to put our observations into data frame. Then we're going to define our df value. We're going to put that to numeric. So you'll see here that we said errors equals coerce. This is just a parameter that we pass to this toNumeric method, and what essentially does is when there is a non-numeric value that cannot be converted to numeric, then it will change that value to a null value, to an empty value essentially. So if it comes across a string that is 1, 2, 3, that will be converted to a number. But if it comes across a string that is ABC, it can't convert that to a number. So instead of throwing an error, we're just telling the method toNumeric to convert that string into a null value, into an empty value essentially. So we want to also make sure that all the dates are of the type datetime. This will make it easier to work with our data. And then we want to say df equals df dot drop na, and that's essentially just going to drop any empty values, but we specifically want to drop it for subset value. We will go through plotting in more detail in a later part. For now, just use what I have here and read through it, and you'll get an idea of what each line does just based on the methods used. So I'm just going to copy and paste this quickly from here. I'll paste it here. And let's just put a comment here, create the plot. So we define a figure of size 10 by 5, 10 across and 5 down. We define the plot. We tell Matplotlib to use the date column in our data frame and the value column in our data frame. And we want to give this series a label called GDP billions. We're also going to add a title called US GDP over time. The X label we're going to call date, and the Y label we're going to call billions of USD. We want to show a grid. It's going to be easier for us to read. We want to show a legend. We're not going to say at this point where exactly to put the legend, but you can do that. And we're going to say title layout, just puts everything nicely laid out within the plot, within the figure rather. And then lastly, we're going to save this figure to this file called US GDP trend.png. Since we haven't specified a directory, it's essentially just going to put it into the directory where this file is, which is here. And we have a last command there, show, which will show us the plot. So let's save that. Go over to our terminal. Let's see that the file is here. There's our file. We're going to say Python. Anytime we want to run a Python file, we need to start off with Python. And we're going to call Fred chart.py. I'm going to hit enter. And it has now shown us this chart as a pop-up. So this is great. We see the chart, we see the legend is here, we see the title as we defined it, the name of the series as part of the legend. We have here the y-axis, billions of USD. We also have the date across the x-axis, and we have the grid lines. So this seems to have worked pretty well. We can close this. And we can go back to VS Code. And over here, we can just use VS Code to actually look at the file that was saved. So we can see here that the file was saved as per our savefig command here. It was saved with the same file name. And we can actually open this directly in VS Code and take a look at it. And there we have our chart saved in our folder. So that all seems to be working pretty well. Later on in this series, we will see how we can modify this script so that we can actually pass it parameters. So instead of having this static series ID as GDP, we'll see how we can turn this into a parameter, which will essentially allow us to then come to the command line, and instead of typing Python fred.py, we can actually then also pass it the parameter that we want to pass, and that would use that parameter to retrieve the correct data and generate the correct chart accordingly. This way you may be able to look at other things and not only GDP. For example, you may want to look at unemployment or federal funds rates, and instead of modifying the actual script, you can simply pass that series ID as a parameter. So congratulations, you've made your first useful script. To recap, today we set up your environment to easily work with Python scripts. We also took a look at virtual environments in Python and how to install different libraries. Finally, we created a simple script to retrieve data from a remote source, do some basic cleanup of the data, and present it in a simple clean chart that is saved as a PNG file on your hard drive. I hope you found this tutorial useful. This is the first part in a bigger automated reporting series that we'll be publishing on veropraxis.com and on our YouTube channel. Please subscribe to our channel so you can get notifications of future parts of this series as well as other series that we'll be publishing in the near future. Feel free to go to our website veropraxis.com so you can follow along with the text-based version of these tutorials and see any other information about us. Hope you found it useful. Click like, click subscribe, and hope to see you in the next part of this reporting series. Cheers.